Hi, all. Welcome to Cloud Native Live today for Wednesday, March 6th. I'm Taylor Thomas, and I'll be the host today. At Cloud Native Live, we take the opportunity to bring in multiple people and technologies from the cloud native space and give them the chance to show how cloud native works and how you can use it in your setups and in your problem solving that you have to do. As a normal reminder here, this is a cloud native or a CNCF sponsored event, and as such, it is governed by the CNCF Code of Conduct, which boils down to be nice and respectful of people. So please do not put anything in the comments or any or in any other form that would be disrespectful to other people. So with that said, I'm going to go ahead and hand things off to Alex, who is from Serboss, and he's going to talk a lot about a bunch of really interesting things around authorization and authentication, all those kind of things we hit. So Alex, I'll let you go ahead and introduce yourself and go ahead and share everything.
Great, thanks, Taylor. Hey, everyone. I'm Alex Olivier. I'm one of the founders of the company behind the open source project Serboss, and we are in the authorization space, which I will go into much more detail on. But today we're really going to be talking about the nitty gritty of what it takes to actually implement a scalable authorization solution inside of your environment, be it cloud native or otherwise, for how you can define roles and permissions and actually enforce those in all your different microservices. So just to kick it off, just make sure we're all on the same page. So unfortunately, authentication and authorization are two words that sound extremely similar, especially when they're reduced down to auth N and auth C, as you may have seen. And so just to make sure we're all aligned, authentication in the side of the system is the bit you're doing inside of your application. A request comes in, you bounce a user off to go and authenticate where they have to present some sort of credential. So username, password, a single sign-on type workflow, a login with Google, login with GitHub, that those kind of flows are all used to. And then you get back some sort of verified credential. You now know who that user is. And that flow is sometimes very much coupled as well with kind of your user directory information. So this person will have a role or a group or a scope, and these kind of typical ideas around identity and ultimately kind of the access management piece of thing. Authorization is kind of the next step. So once you know who someone is, you know what group they belong to, you know what team they have, know what role they have, these kind of information, is how do you actually then go down to your application level and actually authorize a particular request? So can this user with this role call this particular method or call this particular API endpoint? And just to be clear, we're talking about the application level here. So you're probably all used to RBAC inside of your Kubernetes cluster, which controls access to resources and namespaces and those kind of things. So we're now talking about the next level up. So actually, the applications you build and deploy in those clusters or in all your different environments, they also need a level of kind of permissioning. So you're building, if we look at a typical Serverless user, you're building an application. It's made up of a number of microservices. You're running it in Kubernetes. You've got some sort of gateway in front of it. You've got some end user application, be it a web app, a mobile app, or something that's hitting the API, making requests. And now in the application inside of your web of microservices, be it in a service mesh or not, you need to actually decide whether particular requests are should be allowed or should be authorized or not. And where we're going to be looking at today is how to kind of scalably manage that in an environment, particularly when you've got a disparate web of microservices, and those services can be in different languages and frameworks and binaries, and it's a very kind of heterogeneous environment where you need to kind of scalably go and actually implement and define this logic across the application architecture. So to kick things off, don't worry, I'm going to go into code now. I'm not going to show you any more content. I have my machine here, a small Kubernetes cluster running using Minikube if you're interested. And basically the architecture of this is we have the end users, they make requests to our cluster. Inside of our cluster, we're running Istio, so we've got an Envoy proxy running. And behind that service is we have, that gateway, we have three services. We have a report service, we have an expenses service, and a user service. And what is kind of typical of kind of transformation projects or kind of evolving application architectures is each of these services can actually be in different languages. So you might have one in Python, one in JavaScript, one in Go, one in Ruby, you might have some .NET thing, etc., etc. And because we're now in the nice world of containers and Kubernetes to orchestrate that, it's very easy to actually spin up these services and actually have them stand alone and kind of manage everything themselves. And it's kind of irrelevant what language they're all written in if they all just expose a REST API or gRPC API, for example. And that's kind of exactly what we've got here. So just to give you a kind of a quick idea, if we go and look at our Python service, each of these services basically exposes a REST API. This one has each of the services in this demo has basically one endpoint where we can go and request some resource. So basically, this one is a typical fast API application. We got some data. You make a request. We then go and look up that particular request by ID from our dummy database, and then return that as JSON. So if I actually go and hit kind of that endpoint in my dummy application, here I've actually got reports, and I'm getting a response back. So this request is coming into my cluster. Istio is managing where to route that request through. And it's ultimately hitting a pod that's running, in this case, my Python application, and returning that data. And then the same thing for my expenses tracking application, except this one is in Node. So I have a Express application, has some endpoint where you give it some ID. It goes and queries the database for a record by that ID, and either returns a 404 or returns the actual expense data. So I can now, funnily enough, do that same call, and it runs. We get that kind of response back. And the third one we have is our user service, which is in this case in Go. We have our kind of like dummy database here, which is just a map for now. And then here we're using Gorilla as the HTTP kind of server. We've defined some endpoints, and again, we have this endpoint where you give it an ID, and in this case, it's like our user database. And this is kind of a very common service you might have in an application where you want all your other services to go and fetch data about your users, or go and look up a user profile, for example, as a common service that your other services call. That's exactly what we've got set up here. So in this case, we're going to query out our database by that ID and return that record back. So at the moment, these services have no kind of authorization in them. So we are kind of like using dummy authentication, where we're just passing in this header of a user ID. In reality, you'd want to actually have this as a JOT token, or some sort of actually verified credential. In this dummy application, we're just passing as a header. And at the moment, I can go and actually look up different records. So here I'm looking at expenses. I'm making this request as an admin, and I can get the response back for this particular record here that's owned by Sally. If I go and look at it again, I've got an expense ID number 2. This is again querying from our Node service. And this one's actually owned by Martin. And I'm actually now going to make this request as a different user. And here I can actually get a result back for a record that I don't own. And this is where typically you'd start writing some authorization kind of logic. So if we go and kind of define what's our basic authorization requirements, let's go and actually go and implement some basic checks on our application. So we have 3 different resource types and 2 different user roles in this setup. So we have admin and we have a user. So your identity provider ultimately will hold the role that user has in your system. Are they an admin or are they a user? And then we basically need to apply this matrix of permissions to decide whether an action should be allowed or denied. So in our expenses service, we have some actions: create, read, update, delete. We're just going to focus on read from this example. And we're saying, okay, to read a record, if you have the role of admin, it should be allowed. But if you have the role of user, you're only allowed to read that record if you own that record, for example. And we have the same kind of logic for our reports as well. So that's how you're going to implement this. Let's go and do kind of the simple check inside of our application. So we have our request. The request comes in. We have our a middleware in here that does our authentication. So we go and request the user's profile, which basically gives us back that user ID that could be extracted from your JWT, for example. And now we want to do some permission checks. So where you may sometimes feel like to start is like, okay, well, let's go and define some check which says like, okay, allowed by default should be false. And now let's go and implement that logic. So in our request, we have some middleware which is doing this authentication, and we're going to go and get the principal. So who's made the request, and we're going to go and actually write this logic which says, okay, there's this an array called roles, and we're going to see whether the roles of that principal contain admin. And if that user an admin, our business rules said that should be allowed. It's like, great, cool, true. So our second rule says, okay, if the user is if the request or the principal in the request is a user, they should only be allowed if they are the owner of the resource. So this is where an example where you kind of migrate from role-based access control to attribute-based access control, RBAC to ABAC. So now in this case, okay, we need to do the same check as before. Let's go and check the roles. Let's see if make sure this person is a this time user. But we also want to check that rule that says, is this person the owner of the resource? So now we have to do another check in here. So now we know this person is a user. We want to go and check whether the ID of the person making the request, so we call it the principal ID, is equal to the owner of this expense resource that we've already queried out the database. And if they are, the action should be allowed. So now this is where we've done a check for if our user is an admin, if the person's a user. And then what we want to say is, okay, we don't want to return any result if the action is not allowed. So in this case, let's go and do something very basic. And we'll say, let's go and return an error message saying like unauthorized, and we can set the status as well to 403. And you would then go and basically go and 401 or 403, basically go and set our response and kind of return that. And that way our APIs is ultimately protected based on that business rule we have, where we're checking the roles that the person makes as a request for it. So that's in Node. Like we're happy, we've got our logic implemented, we've hard coded all this, and we're returning a relevant error. And this would be our kind of first use case of setting these basic rules. So now we also want to have the same business logic for our report service. So I would then have to now go into my Python application, go to my request handler, and basically re-implement the same logic to support this particular use case. So in the world of Python, we are going to go and say, okay, we've got the request, we've got the request, we've kind of got, in this case, the report from the database. Now we need to go and basically re-implement the same logic. So we're going to create that Boolean again, except this time we're going to go, is admin in the principal roles? So it's doing the same logic as in our Node application. So we're now saying if you're an admin, great. Now let's do the same logic if you're just a user. So now this time we're saying you're a user in the roles, but we also need to do that additional check we said where we want to check if the owner. So now we need to do, okay, if the report owner ID attribute is equal to the principal ID, then the action should be allowed. And then if it's not allowed, exact same kind of format as before. In this case, I'm just going to go and copy my snippet to save all the typing. We then go and return, in this case, we return an exception. So now we say, okay, the logical check says the action should be allowed. So let's go and return some sort of error. So now we've got our logic set up, our business logic set up as it should do in our Python application. And then, okay, now we want to do the same thing in our Go application. And I'll spare you kind of the copy and pasting, but we end up basically implementing this logic. So we set up these variables. We go and we then go and fetch our logic, and then if the action is not allowed, then we go and return some sort of error. So now we're going to have successfully implemented our logic based on our business requirements, and our API is now up to date and serving, and our applications are deployed, and we can go and now make kind of requests against these different endpoints. And funnily enough, if I now go and make a request as before, where I'm pretending to be user Sally, trying to request a resource owned by Martin, I'm going to go and get that 401 unauthorized response with some sort of kind of error message returned. So it's not great. It's amazing. We've kind of hit our requirements, and we can go and live happy lives and never have to think about it again. Reality, as you build applications, as you evolve application services, and your business requirements change, what happened is like, okay, we now want to introduce a more fine-grained permissioning model. So now we want to go and add this concept of like a manager role. So we need a more fine-grained role. We can no longer just divide up people between admin and users. We also now want to have this kind of higher, we want to have this more granular role of like a manager. So now for a manager, our logic now says, okay, if the user is an admin, it should always be allowed. If our user has the user role, they should only be allowed if they're the owner for reading. But if they're a manager, we say, okay, they don't have to be the owner, but they have to only be able to access the resource that's in the same region that they are a manager of. So all of our expenses and all of our reports in our kind of database has a field called region, which dictates which region that particular resource belongs to. And then each user that we have also has a region associated, and we can actually go and look at those user roles here. So here are different users. We have an admin. They have the role of admin and user. They have attributes, name, and department of region. Sally here has the role of user. Again, name, department, region. And then our resources also have a similar model where we have a region associated with it. So I've now kind of got my new requirements. I need to go back into all my application code. Again, 3 different services, 3 different languages. I may know enough JavaScript to go and implement the Node one. I might know just enough Python to go and hack my way through the Python implementation. And I'm just going to be blind guessing for Go because that's just not my day-to-day job, or it's not my first language, let's say. So we basically this is going to take time. You're going to have to do more testing. You're going to have to go and redeploy all the application services, update the logic, etc. And hopefully you can now kind of get an idea of what pain might be involved is as these requirements keep changing, that you have a new feature, you have a new product, you have a new user role, you want to enable more access, more fine-grained access, you're going to have to go and keep touching this application code over and over and over. So there is a better approach here, which is implementing what we call decoupled authorization, in kind of the term that's used for it these days. So I still want to have my single entry point. So my user is authenticated, a request comes in, hits my service mesh. That request then gets routed through our application. But now rather than having each application hard code all this business logic, let's actually decouple that logic out into a standalone service. So this, in a kind of formal specification term, is referred to as a policy decision point. And a policy decision point takes a request of here's this user or principal trying to do this particular action on this particular resource. It evaluates that request against some policy and then simply returns back to the application and allow or deny decision. So let's go and do kind of exactly that. So here I have my serverless policies. This is, again, just YAML definitions. Hopefully, we were talking CNCF Kubernetes world here. Everyone's happy with, well, okay. Everyone knows YAML. They're saying maybe not everyone's necessarily happy with YAML, but you're all familiar with it. We've all got tooling. We've got IDEs that give you nice autocomplete, et cetera, et cetera. So this is the serverless policy that's going to sit behind our expense for our expenses system. And we have one for our reports, and we have one for our user service as well. And each of these policies defines the different resource types in our application. And for each of those resource types, we define the different actions. So here we have create, read, update, delete as kind of the ones we're talking about, and we're going to focus on this kind of read example. And then for each of these actions, we have different rules that define when those actions should be allowed or denied. So for example, here we have a read rule that says the action should be allowed if the user has a role of user, and then this expression or this condition must also be true. So this replicates that same logic we were doing in our application code, but in a kind of much more agnostic way, in a declarative way as these policy files, rather than having to hard-code our logic. But we still essentially do the same thing. We're looking at the request, we're looking at the resource, we're looking at the owner ID, and we're just seeing whether that ID is equal to the ID of the person making the request. And for this new manager role, we have this new manager role defined, and then we're doing that check we were talking about, where we're checking whether the region is equal to the resource is equal to the region of the manager making that particular request. So here we're defining this logic centrally. Same thing for the report, same thing for our users. And now we need to actually kind of go and enforce this. So our first step is actually to go and deploy these policies into our environment. So I'm using Helm here to deploy into our application. So I have a deployment. I'm deploying a new service into our cluster. This cluster, this deployment then deploys the serverless container, and the serverless container has into it loaded in those policies. So that's now all deploying. We can see down here that our serverless container is starting up. It's great. It's all up and running. We could go and actually go and get the logs from that. Logs follow servers. So that's now up and running. The policies are actually already loaded into it. In this case, it's kind of baked the policies into the container itself. We do recommend much more of a kind of a GitHub style approach, so you can actually point serverless to load those policies from a GitHub repo, or any Git repo. You can point them to like a storage bucket, a cloud storage bucket, or even to a database. And for this example, we're just loading it from disk. But ultimately, these policies are now loaded into our application, into our decision point. So this policy decision point is now up and running in our cluster. Now we need to actually go and update all our application services to point to it. So if we start off with Node, before where we had all this if-else hard-coded logic, we can get rid of all this. We will then go and connect up our policy decision point. So here we're using the Serverless SDK. And the way the Serverless SDK works is you basically pull it into your application and you point it to an endpoint. So you've deployed the Serverless container inside of your cluster. It's all local. It's all environment. You completely air gap it even. It's all open source as well, so you can go and fork the repo if you want to have your own copy of it, etc. But we're basically pointing our SDK to where that service is running. And in this case, we're just passing an environment variable which points to, in this case, serverless.demo.cluster.service.local. So it's all running inside the environment, and we're actually using the gRPC SDK in this case. And then in our application code before, where we were doing all this if-else style logic, we are going to replace that with a call to serverless using the SDK. So all this disappears, and we replace it with this call. So here we've got our expenses object kind of from a database, and we've got our principal, which is the same object we were checking before. And then rather than hard coding all that if-else ourselves, we then just call out to the Serverless SDK, and there's a method called isAllowed. We pass in the principal, we pass in the resource, and we pass in what action must be required. This is now in our code, and what we get back is a simple binary, well, Boolean. Is this action allowed or not? So this method behind the scenes, the SDK is making a request to that Serverless instance inside of the cluster. It's saying, here's my principal, here's my resource, here's my action. That decision point, that Serverless container running alongside the application, is going to make a decision based purely on those inputs. So Serverless itself is completely stateless. The only thing in there is policy. And this kind of decoupled approach is very scalable because you can then just horizontally scale your decision points. And with the case of Serverless, we recommend running it actually as a sidecar. So there's one inside of every pod. So you're not going to do any off-node hops, etc. But that request goes over principal, resource, action. What comes back is a Boolean allow or deny. And so our same logic as before, which was simply, if it's not allowed, return an error. If not, return some sort of return the actual data. Still works. So that's now set. In the world of Python, funnily enough, we do the exact same thing. So I'm going to take out all the logic we hard-coded. And we've already pulled in the SDK as before. We have this variable. And then we do the same call out. So here we're calling our Serverless SDK. We're doing the exact same thing where we pass through the principal and the resource we're currently accessing. And then if the response is allowed, then we do that. If the result is not allowed, then we're raising an exception. And if it is allowed, then we are going to go and just return kind of that data. And funnily enough, the exact same thing works in our Go application. So we are going to take out all the logic we did before. I'm going to just go and enable the Serverless SDK, which I will show you what that looks like. But we have this basically create client method where we go and grab the configuration again from the environment variable. We create a new connection to that Serverless decision point. And then in our application code, we then go and do the API call out to go and check the permissions, passing in that principal, resource, and action. And then what comes back again is that same Boolean. So that's actually now all up and deployed and running. And our application is authorizing requests as they come through. So if I go and make the same call, we're actually getting that access denied type logic again. But now if I go and pretend to be a manager for the correct region, so here I've changed my identity, my principal, to a manager, and our business rules that says if the manager is from the same region as the resource, then the action should be allowed. That's now implemented. This response now comes back successfully. Whereas if I go back to being a user, let's say we're getting the correct access deny message. So what this all now means is all our authorization logic is now abstracted out. So we can actually then go and completely go and evolve all of our authorization logic simply in these policies. So from now on, when we get that new requirement from users or the business or such, where we want to add a new role, tweak the logic, etc., I no longer have to touch all my individual application services. I don't have to go remember how to write JavaScript. I don't have to remember how to go and write Python. I don't have to remember how to write Go. I can only keep so much in my head, and 3 languages is more than enough. I don't have to worry about that. Once the SDK implementation is done, once the service is running inside of the cluster, the only place where I have to go and touch my authorization logic is inside of these policy files. So I can go and change this logic. I can make that make that change. And then the container will pick up that logic, and all my application codes that are calling out to the Cerberus containers or the Cerberus instances inside the cluster will start serving based on that new authorization logic with no extra work required. That is the core of authorization and decoupled authorization at that. In these heterogeneous environments that we seem to be building more and more these days, decoupling all this out into a standalone system, into a standalone service, into a standalone policy language, just opens up way more flexibility and scalability in terms of how you architect and build systems. I'm sure many of you are going through these kind of big still migrations, maybe monoliths into microservices. One of the first things you have to worry about when you start breaking big monoliths down into separate services is how you handle common kind of functionalities like authentication and authorization, logging metrics, all these sort of things. Cerberus is a solution for the authorization piece. It is a completely open source. We are like a very proud CNCF member. We've built all the tooling, again, all in the open. You can find out more about this at cerberus.dev. Hit us up on GitHub, github.com/Cerberus. We're all open for contribution and collaboration. And hopefully this has given you a bit of a flavor and a bit of an idea of kind of how decoupled authorization works. You can find out a lot more on our website and up on our repos, and also documentation. We have things like full CI/CD integration, so you can write unit tests against authorization policy, which is something which is quite hard to do if everything's hard-coded into your application. By abstracting it out, it gives you all these nice benefits to test and isolation and such. And with that, I would like to say thank you for your time. Please go and check us out and hit us up on Twitter/X. We have a very active Slack community, and we'd always love to speak to you. You can see right on our homepage we have the speak to an engineer button. You can actually book in and get some time with myself or one of the other team where we can actually help you get up and running ASAP with your application and with your policies. And we can do this actually through an interactive IDE we have available just at play.cerberus.dev, so you can test things right in the browser without having to spin up a whole cluster as well.
Awesome. That was great, Alex. So for those on the stream, if you have any questions, please feel free to submit those, and I'll make sure those are displayed and sent over to Alex here. But I also wanted to ask just a couple questions that came up that I think might be interesting for a lot of people. So you mentioned about there's different ways of managing policies. So what tools do you have to manage like your different policies? And then like I know you'd mentioned GitOps and databases, but what do you see your users doing most often? What do they use to manage those? Because that's a common problem as these things continue to expand and as you get more complex logic.
Yeah, absolutely. So we are big fans of the whole GitOps approach, as I'm sure many of you are as well. Being able to actually write your policies statically and commit those into a repository, which are versionable, auditable, manageable more than anything else, is kind of what we see most. We have a very pluggable storage backend, but the Git repo ultimately is the one that we see the most usage of. Because of all the usual benefits we get in terms of GitOps, etc. And as I mentioned earlier, we've also released, again, as part of the open source project, the CI tooling as well. So as well as defining your actual policies, you then define fixtures for your principles and your resources, and then you can define a full test suite of what your expected permissions should be. And then in your existing CI pipelines, you just run the Cerberus test command, ultimately point it to where your policies and tests are, and then it will evaluate everything that you've defined and give you kind of the usual test output if things aren't as they should, or give you an all clear to then move on with your environment. we using very much like a branch-based or tag-based approach, as you're probably already using for how you actually deploy your application. It's also what's recommended. So when you deploy a serverless container, if you use the open source project, you can actually point it directly to your repo and say, okay, pull in this tag or this branch. We also have Serverless Hub, which is our managed control plane that sits on top of the open source project, which allows you to do much more of a managed CI style environment that coordinates rollouts as well.
Awesome. That's great. We also have a question from YouTube. I'll show that on the screen too. And it's, how does this integrate with JWT access tokens?
Great question. So Serverless is completely agnostic to any particular authentication provider. Hopefully you kind of saw in some of those code snippets that basically it's down to the application to pass the identity through, where you will send from your application the particular identity. Now, given that most authentication providers today are basically issuing JSON Web Tokens, JWTs, JOTs, pick your pronunciation of choice, Serverless natively supports those. So when you deploy a container, you can also point it to your JSON key set, JWKS, that one. Again, I don't know what the standardized pronunciation is these days for that. But you point it to your key set, and then you basically have two options. Inside of your serverless decision point, you can say, just validate the token and pass the data into the policy, or you can actually set it to verify the token as well. So it will actually, using your key set, validate the actual token before passing it into the application, and you can actually set your serverless instance to either reject the request if the token is invalid or just log a warning. But what this now means is any data that's inside of your token, be it scopes or any other kind of data you're setting inside of your token from your identity provider, can then be used inside of your authorization policy. So checking a user's scope value, or maybe checking some custom attribute based on maybe what department that the user belongs to, all that information that is generally inside of your IDP system, you can then just pass directly into Serverless without having to do any kind of data manipulation. You can just pass the full token through and have Serverless actually consume that token and make it available. So what that now means inside of your policies is you can then check any fields and such inside of the token and get very specific and reuse your existing maybe your authentication tooling, also in authentication mechanisms with authorization with Serverless side.
Thank you. One more question from YouTube as well, and that's, how can you write can you write complex policies with code?
So one of the kind of earlier design decisions we made with Serverless, because we've been working this project for about 3 years now, is actually, if you really look at where the requirements for authorization sit, it's not you as the developer, it's not you as the implementer. It's going to be with, inside of a company at least, it's going to be with like the business mind on the business side of things. So be it the product manager, the product owner. We've seen examples where actually it's like the sales team or the support team kind of dictate and control permissions to users' accounts and those sort of things. So what we decided with Serverless early on is we didn't want to have it as code in the sense of Go, JavaScript, etc., because we wanted something a bit more kind of agnostic and maybe it's a bit more readable to maybe someone that isn't a day in, day out dev. So we landed on YAML just because there's a very rich ecosystem of tooling around it. There's nice visualization tools. We do things like publish the schemas for those, so you can light up your IDE to give you full IntelliSense autocomplete style things, feedback as well. And what we've actually seen through the adoption of the project over the years is actually we get feedback like, oh, I'm the product manager, or I'm the CISO, and for the first time I've actually understood what the authorization logic is in my application, because all I'm looking at is these policy files. I don't have to go and understand Java or Go or another language to actually really understand how things are implemented, because we believe it's better for the person that actually holds the requirements to really understand what's going on, and using YAML, which has a rich ecosystem of tooling around it, kind of it's a bit of a leveler for everyone, and we have plans as part of our commercial offering on top to make that much easier to use even further. But the approach of decoupled in something that's agnostic, the schema is very simple. Those conditions I was showing you, like checking the owner ID, etc., are hopefully very readable to you. They're using Cell Common Expression Language, which again is a Google open source project. It's used inside of Kubernetes as well. So if you're familiar with that, you can get up and running very, very quickly. But the whole philosophy is even the most complex policies should be in something that's readable without necessarily understanding or knowing a particular programming language.
Great, thank you. So another question from my side, after watching all the things you were showing, is a question around: is it possible to extend the policy engine? So can you extend it with some other, like either plugins or whatever, to be able to do something more complex? This is kind of related to the code kind of thing, but on a different level. So is there support for that, or is that more of like, no, we consider that kind of out of scope?
Yeah, so we trying to keep the design of serverless as simple as possible. And not because we're being lazy, but because when you really get down to authorization, this is in the blocking path of every single request to your application. So you need the authorizations to the decisions to be as instantaneous as possible. And this is why we actually made the very early decision to make the serverless policy decision point stateless. So at no point did I mention anything about having to synchronize information about your users or your roles or your resources into some sort of authorization service. The only thing that's loaded into those serverless containers is the actual policy files. All the other context is then provided at request time. The downsides of maybe having a system having to synchronize state, if we go with that first, is you now end up with like eventual consistency, cache misses, latency type issues of getting updates about resources or users to your authorization layer. That's going to actually result in people trying to make calls to your API and getting incorrect authorization results because the data isn't being refreshed yet. The second thing around this as well is there are what you also don't want to do is, because your policies can change based on your business rules independently of your application code. If you were to have your authorization layer kind of going out and fetching state, like doing some lookups or kind of plugins that way, what you could end up doing is what may seem like a small change in your authorization logic could actually result in unexpected load in other parts of your system, because now it's having to go out and fetch other state from maybe a different service or application or database that isn't ready for that load or isn't ready for that scale. And I come from a background of building high throughput, low latency, talking like 50 odd billion requests a day type systems, and I've made every mistake possible at that kind of scale. And one of those was trying to push state or do like arbitrary lookups and things at request time for every single request, and that's when you run into all sorts of these issues. So going back to authorization being in the blocking path, every design decision we made so far with serverless is with that in mind, to make sure the lookups are as instantaneous as possible. That's why we say like run as a sidecar, use gRPC API rather than the HTTP one. Keeping the state outside and passing in at request time, always use the latest data, etc. Keeps everything as performant as possible while still getting all the benefits of this decoupled approach.
Okay, thank you. The other question I have around this topic is when we've seen people use this before, and I know like from my personal experience working with people implementing these kind of things, there's always a need for audit logs or
Yes.
policy decision logs. What kind of support does Serboss have for that, and what does it look like to enable or to consume?
Absolutely. So I hadn't touched much on kind of the decision point side in this talk, but one of the big advantages is in this example we had 3 services. We had the one in Python, one in Go, one in Node, all doing permission checks ultimately. And if each service was doing its own checks itself, each service is going to have its own implementation of how it does logs. So you might just log out a JSON line, one might just do a clear text, one might just be no logging at all even. And if you were to then try to understand all the decisions and all the access controls and such that were happening inside of your application, in the kind of that model, you're then going to have to go and basically fetch logs from multiple different services and try and get them into a similar format, etc., etc. One of the big advantages of all decoupled authorization approaches, not just Serboss, is that there is a central service where all these decisions are being made. So all these requests are going through that central service, and horizontally scales central service, and thus every request it can be captured, and every decision made by a serverless decision point produces an audit log, and that audit log it's a JSON structure, and it's timestamp. So at this time, this principal, this ID, these attributes, is trying to do this particular action on this particular resource with attributes, etc. And the resultant decision was either allow or deny. That allow or deny was matched by this particular policy for this particular commit hash. And that is a standardized log. So regardless of which service is doing permission checks, where in your architecture that permission checks are being done from, that log will always be generated before a decision is returned back to the application. Now, those audit logs you can configure where they're sent. So by default, Cerberus will just log them to standard out, and then you'll generally plug in your existing log collection system. So if you've got FluentD or something running inside of your cluster, you can pick up those logs and send them anywhere. If you're running like a cloud infrastructure, you might have cloud logging or CloudWatch and those kind of things that will pick up those logs quite happily. But you can also configure it. So you can write them to a file. And we actually had a big contribution from one of our community members that wrote a Kafka sync for it. So actually take those audit logs, put them onto a Kafka, or point to a Kafka broker, and then those are now in a queue, which you can version, etc., etc. But it's a pluggable backend. It's extremely flexible. By default, that's standard out. Gives you extreme flexibility to use any tooling to push it into anywhere, be it a self-hosted like Loki type thing or a commercial product, Datadog, those sort of things. It's extremely flexible, but the key thing here is every decision that goes through a decision point gets that audit log that's in a stable format, in a consistent format, and always guaranteed to be produced in the same way for every decision made inside of the stack.
Great, thank you. I also saw some comments come in from Twitter about how audit logs are important. I think you really tackle those things, being able to ship it wherever you want to, hot tiers, cold tiers, like whatever you need to do,
Exactly.
It exposes it for that. So that's great. Another one that I think is a practical thing, given how many languages are used across different companies. What languages do you have SDK support for?
Yeah, so the core of Cerberus is written in Go. That's the open source project. Go and have a poke around if you so wish. And the interface that exposes itself, if you don't want to use an SDK, the Cerberus decision point exposes a gRPC by default, but also an HTTP version that sits on top of the gRPC interface. And we've actually then gone and code-genned SDKs for pretty much every language now from that using the protobufs. So we have pretty much every language that's commonly used, we now have an SDK for. And if you're using some esoteric language or one that maybe hasn't got the functionality you need just yet, you can just fall back to using directly the REST or the gRPC API as well. But you can find all these if you just go to the ecosystem page on Cerberus.dev, and it takes you off to all the different SDKs that we have produced. And again, we've had a few community contributed SDKs as well, which we're very thankful for, and always open for more.
Awesome. Well, with that, I'm out of my questions, and I'm not seeing it. Haven't seen any more come in from the live stream. So I think we're probably at a pretty good stopping place. Was there any other calls to action or things you wanted to close with, Alex, before we close out here?
Yeah, I'll just say, please go give it a try. It's a complete open source project. Cerberus.dev has all the relevant links, and we are more than happy to go and jump on a call with any of you and kind of walk you through getting you up and running, and help you even write your first set of policies in our playground. But yeah, please don't reinvent the wheel of authorization would be my main takeaway. It takes too long. It's not worth the effort, and there's already solutions off the shelf that will do it for free as well.
Awesome. Well, thank you so much, Alex, for the presentation and walking through everything and showing how this all works. If you're interested, please visit any of the links we've been sharing throughout the stream, and we hope to all see you at the next Cloud Native Live. Thanks, everyone. See you.